Calculate the volume of the solid generated by rotating the region between the curves y equals x cubed, y equals 8, and x equals 0 about the line y equals 8. This is a takeoff of the one that we had done in class. In class we rotated this region about the y-axis, and then after class someone came up to me and asked me, what if we rotated it about the line y equals 8? So let's take a look at that. So y equals x cubed has been graphed, y equals 8, and x equals 0 is just the y-axis. And we're going to rotate this about the line y equals 8. Now this makes the problem more difficult. It is true though that the region is flush up against the axis of rotation. When we draw a typical rectangle, we recognize that when we rotate that, it generates a solid disk. Our job is to figure out what is the radius. But when the radius is removed from the x-axis, it becomes a more difficult problem. We have this length that goes from the x-axis up to the axis of rotation, which is 8, and then we have this length that goes from the x-axis up to the curve. The distance off the x-axis is called y, and so we'll call that x cubed. Now we're going to do disk method, but when you do disk method with a vertical rectangle, it'll be moved horizontally, so it's going to be an x. And it's the subtraction of these two that gives us how long the rectangle is going to be. So 8 minus x cubed is the radius in terms of x. And now we're ready to set it up. We just need to know the limits of integration, and I have marked this off here where we start at x equals 0 and we're done by the time that x is equal to 2. That would give us the fact that y is 8 when we cube it. So the generic formula for volume by disk would be pi r squared from a to b, where r is some function of x in this case. And so we take 8 minus x cubed and we square it, and we go from 0 to 2. There's no way to integrate this in the standard form that it's in, and so we must square everything out. So when we square out, we get 64 minus 16x cubed plus x to the 6th. And it's just a polynomial integration, and so we'll get 64x. Now for the next term we'll get x to the 4th over 4, and that 4 can cancel the 16, and it becomes 4x fourth, and a negative there. And then we get x to the 7th over 7. It's just our job to put a 2 in and put a 0 in, following the fundamental theorem of calculus. So we put a 2 in, we get 128. We get 2 to the 4, which is 16, times another 4, which will be 64, and then we get a 2 to the 7 all over 7. And so that's another 128 over 7. And then we put in 0, of course, and we get 0, thankfully. Don't forget about the fact that pi is on the outside. So then simplifying, we get 128 minus the 64 plus 128 over 7. Now, here's the key. You want to put together the things that are alike before you start dealing with the fraction. And so, well, 128 minus 64 is just a 64, positive. And so now we're looking at 64 plus 128 over 7. And to make your life easier, you don't have to get a common denominator as it stands right now. If you recognize something that you can factor out, please do that. And so 64 and 128 share 64 in common. So it's best to factor out the 64, and then you're dealing with smaller fractions. After factoring out the 64, you're left with just 1 plus 2 over 7. And then we'd much rather put those two fractions together, and that's just going to be simply 7 over 7 plus 2 over 7, or altogether 9 over 7. Times that 64 pi, and so now we just have to take 64 and multiply it by 9, and we end up with 576. The final answer is 576 pi over 7.